Good afternoon, my fabulous chemistry students. Video lecture number 2. Today we are going to delve deeper into this whole oxidation number and the rules of how we assign them, okay, within a chemical compound. Hopefully this notes one won't be too long. I think the next one might be the real long one. I am trying to go a little bit slower too, so I apologize if the notes videos are getting a little bit longer, but I've had some complaints that I'm just going too fast, Mr. Milks. So, we need to determine the chemical formulas from charge cancellation technique, or what we call the crisscross, and that we're going to use that basically backwards to determine in a compound what the charges are. So, the rules for assigning oxidation states. First rule, uncombined elements. So when they are by themselves, like we saw in last video, their oxidation is always 0. So you got to remember this. This is something we have to commit to memory. Al plus Na is Cl2, H2. Notice they are all 0. Whenever I have an element by itself, and that includes the diatomics, the charge is 0. Because it's a lone element, it is not in a compound. Now, in compounds, the sum of the charges for all the elements must equal 0. And I'm going to actually change it in the next one because it actually has to equal the charge of the compound, actually. And in NaCl, the charge of the whole compound is 0 because it's a stable compound. Okay? So I have one Na, I have one Cl. Okay? And I look on my periodic table, I got a +1 and a -1. When I add them together, they form 0. So let's do it again here with Mg and N2. It'll work as a quick little refresher. A periodic table, I have one choice for my Mg. It is a +2. So if I have 3 times a +2, I get 6. For N, the top one is -3, but I know it's actually going to work because I have -3. If I have 2 times a -3, I get -6. 6 and a -6 together equals 0. Now, let me show you real quick what would happen if I chose, because I also have for nitrogen a choice. I could take -2 or -1. Okay, let me just show you what would happen if I chose one of those other numbers. Let's say I was looking at this problem and I see, oh, Mg is a +2, so let me do this in black because it's wrong. Let me do N is -2, so they equal. Well, let's do the math. I have 3 times +2 for the Mg is still going to be 6. But now let me do the N. I have 2 nitrogens times a -2, and that's going to equal -4. 6 minus 4 is 2, which is not 0. So you see how I can use this rule kind of backwards. And I'm going to dwell on this for a minute to make sure we got it, because these are some of the very simple things, and I really don't want to see you guys make any mistakes on this. Now, the third example is a little bit more complex because I have 3 things. The part about it that is good and going to lead us into some of these other rules is there are some limited options on some of these guys, so that we're going to use that to our advantage. Hydrogen could be +1 or -1, but it's first, so I know it's got to be positive. So that's +1. Oxygen has got a -2, and it is pretty much only -2. We're going to find some rules where it's -1, even though it doesn't say it could be, but you're going to find that there are some exceptions. This is chemistry. So now we don't know N. N could be -3, -2, -1, +1, +2, +3, +4. We don't really know. But so what we're going to do is let's do the math of what we got to figure out what N has to be. So hydrogen, I have 1 of them times a +1. So that gives me a +1, right? Oxygen, I have 3 of them times a -2 charge gives me a -6. Well, now how can I get all this thing here to add up to 0? 1 plus what? -6 equals 0. Well, I know I got to do 6 minus 6 to equal 0, correct? I know that's the case. So I need this charge to be plus 5, because now 1 plus 5 is 6, and then I can get 6 minus 6 to be 0. So if I go backwards, I say I have 1 nitrogen at what charge gets me a plus 5 charge? Well, it's got to be a plus 5. So now I get a plus 5 for my nitrogen. And that is the game that we need to play with atoms with like 3, right, with molecules with 3 atoms. And that's the game we'll play for the middle atom every time. So, a little bit more. Rules for the wiser. Oxidation number is the number inside of the parentheses. It is the charge on only one atom. So if it's a diatomic, it still just has to be for 1. I have to use those rules. We almost always write the positive element first and the negative element last in the compound formula. Very rarely does that ever change. I believe the coup is the only time I've ever seen the negative come first, and that's just a crazy thing. So it just happens like that. Trick, you can keep the polyatomic ions, of course, together and use the charge in table E. Example, HCl, exception to this rule, NH3+. I do HCl. There's a +1 and a -1. NH3. Well, so here's where the exception is. So N in 3. I believe hydrogen is a +1, which gives me a total of +3. And that means nitrogen needs to be a -3, and it's written first. Or could I do it the other way around? Nitrogen is a +3, hydrogen is a -1, it'd be a -3. So both work, and I have no way to know which one is which. This is the exception. Okay? This is the exception. And this is when this is the exception for hydrogen when it's actually a -1. So this is a +3, and this becomes a -3. Okay? Here, the example, hydrogen's a +1. Here, hydrogen's a -1. An exception. Positive comes first. Group 1 metals always have a +1 oxidation. We did that in periodic table. Okay, group 2 metals always have a +2 oxidation number. So I need to find the oxidation numbers of these. Lithium, I look on periodic table, is a +1. I have 1 chlorine, it's also a -1. Mg is a +2. It's in group 2. Cl is a -1. Just remember I have 2 -1s. So, but I remember in the last slide, it said the charge up here has to be the charge for 1 atom. 1 atom of chlorine is -1. We have to do it that way to keep everything right. Fluorine is always a -1 in compounds. The other halogens are also -1. So in this case, fluorine's going to be a -1, hydrogen's a +1, chlorine's a -1. I have 2 of them, so calcium has to be a +2. Bromine's a -1, so sodium has to be a +1. Notice they all add up to 0 and work out. 5. Hydrogen is a +1 compound unless it's combined with a group 1 or group 2 metal. In this case, it's a -1. Okay, so HCl +1 because it's here, and here it's with a metal, so it's +1 and it's -1. So I need to go back because sometimes we get things screwed up. This is the exception to the positive ion coming first. This is going to be a +1 and a +3, and the nitrogen is a -3. The exception is the N being a -3. It's tough to determine which one there is the exception. Could have been either. And we are good on this page. Yes, we are. On to 6, and we're almost done. Oxygen is usually -2. It's almost always a -2. There's got to be specific rules for it to not be -2. And so when I see oxygen, one of the first things I do is assign it a -2. That's a trick for most of these. When combined with specifically fluorine, it becomes a +2. Because fluorine has got to be a -1. There's 2 of them, which is a -2. So I need a +2 to cancel it out. And when I see peroxide, that's when it's a -1. And the tricky part about this is that we have to memorize these because this isn't actually even in the periodic table. Peroxide means when I have an O2 at the end of a compound. Notice H2O ends in an O. All right, it's not in a O2. In this, so here I see the O2, so that's a ding, ding, ding. It's a -1. 2 -1s is a -2. Na is a +1. 2 +1s is a +2. Same thing here. Oxygen is going to be a -1 because of the 2. I have 2 of them, so the total is -2. I need the total positive charge to be +2. So hydrogen is a +1. Now, this piece, the sum of the oxidation numbers, is actually equal to the charge, okay, on table E. So in this particular example, I notice the overall charge is a -2. So earlier on in the notes, it said, well, a charge on a compound is always 0, or the sum of the ions in a compound is always 0. Well, it's because it's an actual compound, not an ion. In this case, it's an ion, and so it's going to equal the ion charge. So I'm going to start there, okay? Then I'm going to say, oh, I'm going oxygen first. This is not a 2, so oxygen is a -2. 7 times -2 is -14. What? -14 is a -2. It's got to be 12. 12 minus 14 equals a -2. 2 divided by, or 2 times what is 12? +6. If I look on the periodic table for chromium, do I see a +6 as an answer choice? And yes, the notes would go by faster if Mr. Mooks could find it on the periodic table faster. But you know how that goes. Where are you, Mr. CR? I see SR. CR is a +2, a +3, and a +6. So we are good. So we just did a whole bunch of rules for assigning oxidation numbers. I did try to take my time with it. It is very important. I need you to be able to do that skill without any problems. But now we have to do the practice packet. And of course, there's got to be practice because we need to be able to do the skill. And I didn't type it in. So I need you to be able to do packet pages 2 and 3 and 5. So practice pages, or packet pages 2 through 5, you can do now with basically assigning oxidation numbers using the technique of what other elements it's bonded with. And remember, if it's by itself, it's got to be 0. See you guys in class.